First speaker, I decided to place someone from Milan because I thought that no one will arrive in time, although also the last train arrived, so I was totally wrong. I'm starting with the right foot. The first speaker is Asia MOTALLI. She is a PhD student here, and she works in the lab of Professor Esposito, and she will talk about cardiorespiratory and gas exchange adaptation to exercise in e-cigarette users. The stage is yours.
Thank you for the presentation and the introduction. Hello everybody, good morning. And thank you for the opportunity to share my PhD project at the moment. So,
that's only the pointer. So, left,
okay.
10 seconds more for you.
Okay. It's well known that cigarette smoking impairs the cardiovascular and pulmonary systems, and the effects are already known. And cigarette smoking is the first leading cause of mortality worldwide, with some alteration on the cardiovascular and respiratory system, as well as the skeletal muscle function and metabolism. And taken all together, this alteration impairs the exercise tolerance and exercise capacity, not only during maximal exercise but also during moderate intensity exercise, as previously observed in some studies in our laboratory, even in young and active smokers. However, in the last few years, we observe a widespread transition from cigarette use, traditional cigarette use, to electronic device. And in this case, we have a very heterogeneous world for these devices with different physiological effects. For this reason, we decided to focus on one single device, in particular the IQOS, which is highly prevalent and widespread here in Italy, particularly in the younger population. And IQOS is a heated tobacco product, which means that there is a system that heats up the tobacco contained in the sticks without making combustion. What we know right now about the alteration induced by IQOS smoking, there are some evidences that IQOS cigarette smoking impairs the cardiovascular responses at rest, but also impairs the pulmonary function, reducing the pulmonary function and the diffusion capacity. And also, there are evidence on the impact of these IQOS effects on a systemic levels. However, despite we know that traditional cigarette smoking impairs exercise response in even young and active individuals, the effects of these IQOS devices are still unknown. In particular, in response to moderate intensity square wave exercise. Thus, the aim of the study is to determine this alteration induced by chronic IQOS utilization, and the hypothesis is that also this type of device can induce alteration in exercise responses, such as lower cardiorespiratory and metabolic kinetics, even in this young population, despite the short smoking history and also the physical activity levels. The participants underwent an initial anthropometric assessment, followed by a venous blood sample. And here you can see the characterization of our participants. Then they perform a pulmonary function assessment with also the diffusion capacity for carbon monoxide, and then the LCO was corrected for the concentration of hemoglobin and carboxyhemoglobin. Then our participants did an incremental step test with a cycle ergometer, and we continuously recorded the respiratory and metabolic response as well as the cardiovascular response to determine the values at peak of exercise. Finally, our participants completed a square wave test at 50% of peak power, and also in this case we recorded the cardiorespiratory and metabolic parameters, and then they were fitted by a mono-exponential fitting model following the standard procedures for kinetics analysis. Moving to the results, these are the main cardiorespiratory metabolic values at rest in our subject, and we didn't see any significant difference for this between the two groups. Here you can see the pulmonary function results, and even in this case we didn't see significant differences between the two groups, even in the DLCO values after the correction for hemoglobin and carboxyhemoglobin. Moving on, we have the results at peak of exercise for the incremental step test, and even in this case we didn't see any significant difference between the two groups. For the last set of results, here you can see the results of the square wave test. On your left, the on phase of the kinetics, and on the right, the off phase. For the oxygen uptake, we saw a significant difference in time constant tau for the ICOS group on the on phase, whereas we didn't see any significant difference for the other parameters, both on the on and the off phase. The heart rate response didn't show any significant differences for any of the kinetic parameters, both on the on and the off phases. Lastly, for the ventilation, we observe a significant difference always in the time constant tau for the ICOS group compared to the controls, whereas we didn't see any significant difference for other parameters of the kinetics. To conclude, despite no significant differences in pulmonary function, DLCO, metabolic and cardiorespiratory values at rest and during peak of exercise, the ICOS group showed us lower metabolic and ventilatory kinetics in response to moderate intensity square wave exercise. Preliminary results are compatible with the cardiovascular alteration already described at rest in ICOS users. To conclude, I would like to thank everyone who is involved in this project, from the Human and Physiology Exercise Physiology Lab, with my PhD tutor, Prof. Esposito, and co-tutor, Prof. Rampichini, and also the LITA Lab with Professor Tringali and Papini for the hematic blood samples. And thank you all for your kind attention.
Thank you very much, first of all, for being perfectly in time. That's 10 more points for her in the next exam. Okay, so the floor is open for discussion, for questions, for whatever. I didn't find anyone that ran around with the microphone, so I have to move. Raise your hand and I will join you. Who is the first that break the ice? Yep.
Thank you for your... yes, Professor Carlo Cappelli, an old dinosaur of the Italian physiology. There are many of them. No, just a short question. You showed us that the VO2 kinetics was slower, as well as the ventilation kinetics was lower. I must comment that whenever you use these lousy breath-by-breath methods for assessing gases changes on a single breath basis, their kinetics of VO2 is spoiled much very much by the kinetics of ventilation. So I think that you should be very careful, or at least address in the discussion. Thank you.
Thank you so much for this.
Any other answer? Oh, yes. Thank you, Anna.
Very, very nice presentation, thank you. Given the slower ventilatory response in IQOS smokers, do you think that it might be worth also analyzing the ventilatory response to hypoxia and hypercapnia and see whether if it's different among the two groups?
Thank you so much.
Anna Taboni, University of Brescia.
Thank you so much. It would be interesting to see also these results. Unfortunately, we cannot lab, but it would be interesting to see how it could change. And I don't know. We'll see how this could differ in a different oxygen concentration in the air. Thank you.
Something more? Yep.
Thank you. Great presentation. Thanks very much. I actually postdoced with your supervisor, Fabio, in California, so please say hello from me. Just a quick question. In terms of the kinetics, to what extent do you think the prevailing oxidative inflammatory stress associated with the smokers, the vapors, is having an impact on the kinetics?
Yeah, I think thank you for the question. And we think for now that it could depend on this inflammation, systemic alteration due to IQOS effects. We also have some vascular measure that I didn't present here, so we'll correlate the two results for this. Thank you so much.
Thank you very much,
Thank you.
Asia. Well done.
Thank you.